All right, chapters 1 through 10 homework is due this Sunday at 11:59. I don't even know the date of this Sunday. Today's the 24th. 25th, 26th, 27th, 28th. So that is the 28th, 7/28/19. And your test is on Wednesday, 7/31/19. And like I said before, your final exam is going to be 33 multiple choice questions, and you're going to take it in class with me. And it's going to be on the computer. I will give you formula sheet, I'll give you scratch paper. You can use your calculator, but I will check to make sure that there's no programs. The only program that should be on there is FixCalc, or you can use one of my calculators. So that's everything that's due. All tests are over now except for the final exam. The only thing I have left to do that's quote-unquote new is section 10.3. We have done everything else. Last class period we did 9.2, 10.1, and 10.2. So all we have left to do today is 10.3. So after I finish 10.3, which y'all is only 4 pages, after I finish 10.3, what we're going to do is start reviewing for the exam. And if you feel like you don't need to review for the exam, you don't have to stay. But if you feel like you need some review for the exam, what I'm going to do is I'm going to start going over those 18 pages. And what I'll do the rest of today and on Monday is just review. Answer questions, go over those 18 pages, just get it back in your head, okay? Now, even though I'm doing it, I'm making it look easy. You need to do it to make sure that you understand it. Just sitting back and listening to me, I'm going to make it look easy all day long, just like when you go get your hair done. She makes it look easy, but then when you try to do it, you can't replicate it. So just make sure that you do it as well. All right. In 10.3, y'all, is really not that much different than what we've been doing. When we are doing hypothesis test again, but this time we're going to do a t-test. And we went back and forth between the z-test and the t-test. We're doing the same thing. We're going to be doing the same steps as 10.2, but finding the rejection region is going to be a little bit different. And just like before, last class period we talked about that the t-test had the standard deviation. This one's going to be the same thing. Your t-test is going to have that standard deviation. So when we're doing this in our calculator, we're going to be doing the x-bar, the s, the n, and the alpha. So this is a hypothesis test for a population mean. This is not much different, like I said, than what we did in the last section. Same steps from 10.2, but finding the rejection region is going to be a little bit different. So here's the rules. Finding the rejection region for a t-test, you're going to identify the degrees of freedom. The degrees of freedom are going to be n-1, and then we're going to do alpha. And then we're going to use table 6 to find the critical, and let me hand out the formula sheets so that y'all can look up what you need to look up as well. Have your socks on yet? No. So we're going to do degrees of freedom is n-1, and we're also going to find alpha, and then we need to use table 6 to find the critical values for t, or the rejection region.
Where is table 6?
Let's see.
I have table 5, and there's no table 6, and it must be table 7.
Hold on, maybe table 7. I think I changed it in my notes, and I did. I changed it in my notes, and I didn't change it up here. 7. I didn't change it up there, but I changed it on my paper. Thank you. Now, just to kind of show you the difference in what we were doing last time we were doing in 10.2 versus 10.3. In 10.2, we were using number 5, which was the one proportion z-test. In this problem, we're going to be doing number 2, which is the t-test. Scroll down so I can write it. All right, we're still going to have to choose, is it left, is it right, is it not equal? So you're still going to have to choose one of those. In 10.2, we were talking about p's. In this one, we're going to be talking about, okay, different letter. This was x, where this is x bar. They both have an n. So just like we were doing last time, the difference between a z and a t is going to be that standard deviation. So if it has a standard deviation, we know that we're going to be doing a t-test. So that standard deviation is the main difference between the two. And if we're drawing a normal curve, here, all those numbers on the bottom, those are going to be z's. Like find your z, find your z. Here, we say find our t, find our t. So instead of z critical values, we're going to have t critical values. But we're still doing the same process. You're still going to have your mean, you're still going to have your standard deviation. We just have t critical values versus z critical values. It's just a different test. Good so far? Gonna move? Alright. So, let me cover up for a second. In 1990, the average height of women 20 years of age or older was 63.7 inches based on data obtained from the Center of Disease Controls and Prevention's data report. Suppose that a random sample of 45 women who are 20 years of age or older results in an average height of 63.9. State the appropriate null and alternative hypotheses. So, we did this last time. This is the ho and the high. The H naught and the H1. The H naught is going to be your equal. So what is my equal to? We're going to be dealing with, what is the H naught going to be? Equal to what?
63.7.
63.7. The average height was 63.7. So now when we do our H1, we have to determine, is it more, is it less, or is it not equal to? Are you with me so far? Yeah.
Yeah, I'm trying to
Figure out what the other one is. Now, in all of the problems that we did on Monday, it said greater than, or it said less than, or it said reduced, or it said blah, blah, blah. Here, our H1 is what we're trying to prove in court. So we're trying to prove that the average is 63.9. So what we're trying to prove is 63.9. So is 63.9 greater than, less than, equal to, not equal to? So we're looking at this number compared to 63.7. So what am I going to put between it? Greater than. So this number is bigger then 63.7. So they didn't use the words like they did on Monday. They didn't say, we're trying to find something that's less than, or we're trying to make the value greater than. They just give you another number. And so they're trying to tell you that today's height is this, which is greater than what it used to be. Does that make sense? Okay? So for part one, all they want you to do is figure out which is the H naught and what is the H1. Now, let's go ahead and figure out what our other letters are. Random sample of 45. So what is 45 going to equal? Our N. The X bar, what is our mean?
63.7.
63.7. Is this right-tailed, left-tailed, or two-tailed?
Right.
It is right-tailed. And the reason it is right-tailed is because this is pointing to the right. It's like a little right arrow. So because this is pointing to the right, that's telling me it's going to be a right-tailed test. Are we good for the first one? Now, did they tell us the point again? They haven't told us that yet, have they? Okay. All right, suppose the p-value for this test is 0.35. Explain what this value means. So our p-value, they're telling us, is 0.35. Let me go ahead and just pull the sentence up and we can talk about it. Darn, I gave myself a lot of room. So if our p-value is 35, that's going to be a percentage or a 35 thing. So we're expecting 35 of the samples. So of these 45 samples, our P is 35. So we're expecting 35 of those 45 samples to have a mean of 63.9. It's 63.7, not 63.9. Hold on. Oh, it is 63.9, because that's the new one. 63.9 or higher. So our p-value is telling us how many out of our sample is going to result in that higher mean. That's our p-value. Now, let's look at C. Write a conclusion for the hypothesis test assuming an alpha of 0.10 significance or higher. Now, I told you that I like to draw the picture. In last class period, we drew the picture over and over, and we found our critical value. We went to the table, and we did all of that. And then I told you there was that other thing that we could use that. So for this one, we don't have the mean. I mean, we have the mean. We don't have the standard deviation. We can't do the picture because I don't have all the data. So I have to use that rule, and I'm going to call it the Snoop Dogg rule. Do we remember what he said? If P is low, the hoe must go. So the other rule, if you can't draw it, says that if your p-value is less than your alpha, you reject it. It must go. So if your p is low, if your p is less than your alpha, if your p is low, it must go. You must reject it. So if your p is low, it must go. So for this problem, what was my p? My p is 0.35. So my p value is 0.35. What was my alpha?
0.10.
0.10. So is the p less than alpha?
No.
No, so does the hoe go? We keep H naught. We do not reject it, we keep it. So down here, let me pull it up so you can see it. Since P is 0.35, which is greater than P, alpha equals 0.10, we do not reject the HO or the H naught. We keep it. So that was that second rule. So if you can't draw it, you're going to say if the P is, if the P value is less than alpha, you reject it. Or if the P is low, the hoe must go. However we can remember it. So if your P value is less than alpha, you reject it. It's got to go. All right, let's do another one. Cover up. Do students who learn English in another language simultaneously score worse on the SAT than the general population? The mean score among all test takers is a 501. A random sample of 100 test takers who learned English in another language simultaneously had a mean SAT score of 485 with a standard deviation of 116. Do these results suggest that students who learned English as well as another language simultaneously scored worse on the SAT? So, first thing they want us to do is they want us to give the null and the alternative hypothesis. So, what is my null and what is my alternative hypothesis? What is my null going to be? Who? The average of all test takers is 501. So now, I've got to figure out what the other is. And it's not going to say, for this type of, it's not going to say, oh, they made higher or they made worse. They're going to give us another score. And this other score is what to the 501? It's less than the 501. So that's going to give me the less score. They did worse. Now, is this left tail or right tail or two tail? This is going to be left tail because it's pointing to the left. Okay, what else do we have? What does this stand for?
Standard deviation. So
My standard deviation of 116. What does this stand for? What letter?
Yeah.
That is going to be my N. And my X bar, or my data, quote unquote, is going to be my mean of the sample of our students is going to be 485. So, the average of all test takers is 501. My data is going to be less than 501. The average of my data is 485. I did a sample of 100 students and their standard deviation was 116. Cool? So all we're doing in part A is we're just giving them all of my data. Well, they hadn't told us alpha yet, but I went ahead and wrote alpha, but I don't really technically know it yet. Pull this up. All right, so now they want me to draw it. Okay, so we have standard deviation, which means we're dealing with not Z, but T. So because we have standard deviation, we're dealing with T. Now, in order to get my critical values for T, I'm going to go to my table. Go to table 7. So on table 7, we're going to do degrees of freedom is N minus 1. So what is my N? What's my N in my problem?
100.
So I'm going to do 100 minus 1. So my degrees of freedom is going to be 99. Now the other thing that I need to know, why have they not? Must have been in the directions. That alpha is 0.1. Alpha is 0.1. So on your table 7, you're going to do degrees of freedom. Now, can you see that when we do alpha 0.1, that's the 1, 2, 3, 4th column over. And when I come down, it goes from 90 to 100 on degrees of freedom. So there is no 99. So I've got to use whatever's closest. So what am I going to use? 100. So even though it's supposed to be 99, there's no 99 on the sheet. So I've got to use 100 and 0.1. So what matches up with 100 and 0.1 on table 7?
1.29.
1.29. So my T is going to be 1.290 from my table. So that's what I'm going to put over here. So it's going to be, now we are doing a left tail. What do we have to do if it's a left tail?
Make it negative.
Make it negative because it's a left tail.
So all T's are gonna be negative?
If they're left tails. If they're right tails, they're going to be positive.
And
So
then-
because we're shading to the left, you want your T to be negative so that you can shade just that tail. Because if you use the positive of that, you would be shading the tail and the belly. We just want to be shading that tail. So you want to use the T that's closest to the tail. And the same thing when we were doing the Z's.
Okay, and where did the,
How do we know it's up to?
well, no, the Jesus fish symbol is,
Yes.
that's the degree of
That's-
freedom?
The degrees of freedom came from n minus 1, where n is 100.
Okay, that's what I thought. So what does that thing stand for? Is
The
it-
alpha,
Oh, just the
they'll give that
alpha.
to you. They'll give that
Okay, so
to
that
you.
was given.
Yeah.
Okay.
Now, the last thing we have to do is we have to figure out what is our data point. And to get our data point, we are going to do, let's see, data point. We are going to do stat in our calculator. Stat over to test. And we're going to do number 2, t-test. Now, when I pull it up, it's going to ask for stat over to test, and we're going to do number 2, t-test. We want to make sure we highlight stats, because we're not sucking data over anything, we're doing stats. So, what do you think we're going to put in for the first one? What is our mu? 501. What is our mean? What is our mean of our data? 485. What is our standard deviation? 116. How many people are in our sample size? 100, or how many groups, or how many? Now, is it not equal to, less than, or greater than? Less than. So, if you're trying to change that, you get on top of it and you just hit enter. So let me pull down, make sure I have some room. So when I hit calculate, that is going to give me what my T is. Here's my T. My T is negative 1.378, so my T is right here. We reject it if it's in the shaded. We do not reject it if it's in the not shaded. So am I going to reject it or not reject it? I am going to reject. So that's going to be the whole answer to the question. I'm going to reject the H naught because that purple point is within the blue shading. Now, the other way to do this is to take your p-value and say, is it less than alpha? Is the p, if the p is low, the hoe must go. So, is your p less than alpha? So your p is 0.085. Is that less than alpha, which is what they told us? Is your p low? Is your p lower than alpha? 8 cents is less than 10 cents. So your hoe must go. So you must reject the hoe. So either way, if you do it by the pitcher, you're going to use the T in the pitcher. But your P, if your P is low, the hoe must go. So your P is what you'll use for lower than alpha. Your T is what you'll use to see if it's shaded into the region or not. They both are going to give you the same answer. So it's just according to which one you want to use. And then down here, just to pull it up and show you.
Because this one was less than the alpha.
Yes.
Okay.
Because 8 cents is less than 10 cents. And then this one shows you why you're rejecting it. You can either show it from the picture or you can show it from your p-value. So those are your conclusions. That's what we're trying to figure out. Do we reject it or do we keep it? All right, I'm going to let you try one. Get it bigger so you can kind of see it. I want you to go through the whole process. I want to know my H0 and my H1. Then I want you to draw it. Then I want you to do the t-test, and then I want you to tell me whether you reject it or whether you keep it. Courtney is here, Paige is here, Rachel's here, James is here, PJ is here, Myers is not, Travis is here, Josh is not, Barrett is here, Monica is here, Rebecca is here, Austin is here, Zalea is not, Equasia is here. And they're throwing in all these extra numbers to see if it's going to screw with you. Ultimately, my final answer, do we keep it or do we reject it? Reject or do not reject? That is the question. Good news, if this was on the exam, you got a 50-50 chance. Reject, do not reject.